Hi, I thought I would do a review of this power supply. When I was on the market looking for a power supply, I couldn't find any reviews of this particular unit. It's the YIHUA, I'm not sure how you pronounce that, 305DB. Now, none of the power supplies in this price bracket get great reviews. Not surprising, really. I suppose you get what you pay for. But I thought the brand seemed to have a bit of a presence out there, so I thought I might get lucky. Also, I thought the memory functions were a nice touch. You're able to set and store multiple different voltage and current limits. And I thought that might be handy for charging different batteries without having to actually remember what the voltage or current limits were for those batteries. Another thing that tempted me into purchasing this particular unit was the serial port and the USB port. Now, I haven't actually used them yet, but yeah, maybe in a later video I can demonstrate how they function, if they function. Right, so the first thing I'll do is demonstrate an issue I've been having with this particular power supply. It's developed a fault. And then I'll show you the quality of the components and show you inside the unit. So maybe you're also in the market for a power supply, and this might aid you in selecting a power supply. Right, so how to operate the unit. That's the voltage button there, and that's the current button. You can set the limit for either voltage or current. And the meter controls to whatever limits hit first. So, for example, the output's off at the moment, but if I decrease the voltage, like so, you can also push the button multiple times to get more or less a higher or lower decimal place for more or less or lower selectivity. So if I put that on 0, and let's turn the output on. Now the output's connected to these leads, and I've connected it to these to this little lamp, little voltage indicator. And I'm going to go back to voltage mode and just increase the voltage there. It jumps between voltage levels because I've got it on the most significant digit at the moment. I guess the rotary encoder is actually, the quality feels reasonably good. If I increase the resolution a little bit, so you can see the voltage steps are very progressive. That's going up, it's going back down again. It'll take a long time to get up and down. That's it. That's a nice touch. So let's now if I increase the voltage slowly, you'll hear a click. There. What that is, this transformer has multiple output tappings here, and they come across to the board. Now, I think these two relays here switch that. That clicking that you hear, I'll just go back to voltage mode, is the relay on the left, going from the lowest voltage to the next voltage up. No issues there. That's working like a dream. If I continue to put the voltage up, I'll enable. If you leave the meter, the power supply unattended, you can see the digits stop flashing and the rotary encoder becomes locked. That's a nice touch. If I go back to voltage and I increase slowly, when I get to about 15 volts there, you can hear it. It's trying to enable the next tapping. And this relay here is switching in and out. Now I think I've gotten very, very lucky here. I'm not particularly good at electronics fault finding, but I noticed that this transistor upstream from that relay has got a big crack in it. So what I'm going to do is, let's get back to focus. I'm going to repair that transistor, and hopefully that does the trick, and I'm able to salvage the time and money spent on this unit. Now, I'll do a follow-up video after the transistor is repaired and maybe show you the meter in action and maybe put a bit more load on it. What I'm also planning to do is add these 2 additional transistors. I've purchased these. They're a couple of dollars each on eBay. What I noticed when I was looking at the circuit board, there's a couple of spare locations for the transistors. These 2 transistors came fitted, and those 2 didn't. Now it might be, it probably is, for a unit with a higher rating. Perhaps there is where this one's 5 amp, perhaps there's a 10 amp unit. But what I did notice, even under low loads, one of these transistors is running a little bit hotter than the other. So, which is not surprising. I mean, even a small change in resistance, the current won't share equally. So perhaps with 4, that'll alleviate that a little bit. These aren't actually the proper heat sinks. These are just pieces of aluminium I cut. Enabled me to move the circuit board around and do a bit of fault finding. The real heat sink is over there, and it's got a temperature sensor, and that temperature sensor actually connects back to the board normally and enables that fan. It does actually work once the heatsink starts to warm up. That fan comes on, normally around 1 amp, 2 amps. The fan kicks on. But this gave me just at least a little bit of a heatsink while I was running it under low load. General quality, not the best. And you can see the paint on these resistors, for example, is pretty shoddy. Soldering, there's a bit to be desired. I touched up some of the points just to make sure that they were well done properly. But maybe I made matters worse. Who knows? These resistors are glued down. Sorry, these capacitors are glued down. But the actual quality of the other components, I wouldn't be able to tell you. Obviously, this transistor wasn't the best. The fact that it cracked right down the middle. Otherwise, that's the serial interface and the USB interface, I believe. The fan seems okay. I guess an EC fan is an EC fan. The transformer is actually relatively solid, and from what I can tell, it actually looks quite well put together. It's pretty substantial. The whole casing or frame is pretty substantial. It's a heavy power supply. You can hear the transformer whining. I'll turn it off and then turn it back on. You hear a bit of a hum. This is I suppose the smarts of the board. There's a little bit of flux and whatnots here. There must have been a manual soldering job, I'm guessing. I don't know if that's a good thing or bad thing. Unfortunately, I don't have the experience to tell you if these are good or bad components or the quality overall, but hopefully this helps you at least a little bit. Look, overall, relatively happy with the unit up until now. It's unfortunate that I've had to waste this much time in fault finding it, and going to be a little bit more time in sourcing that transistor and repairing it. But hopefully after this it runs okay. I think when buying a power supply in this price band, to some extent you're just trying to find the best of a bad bunch. But yeah, hopefully this is helpful to you in your search, and you get a good one. See you later.